Good morning, everyone. The participants online today. I'm really pleased to open together with David this session. Is our steering committee member chair that will officially open the session and greet everyone. And I will shortly introduce speakers today. We have Dr. Lisa Lenz and Thomas Neuhäuser from our buildingSMART chapter working group for openBIM for steel construction. And I will pass directly to David. He will officially open the session, and then we'll. Yeah. Okay. Yeah. Okay. So we're good to go. So then it's fine. Dr. Lisa Lenz is founder and the managing partner of Building Information Management (GLW) and the Building Information Cloud, the company who deals with project management and BIM consultancy. She is an expert in various fields, active and within that chapter, and together with Thomas Neuhäuser, they initiated this activity as an activity proposal with all other players in buildingSMART Germany. Thomas Neuhäuser, he's a group leader of collaborative factory planning at the Fraunhofer Research Institute, and he is also a co-leader of this working group. Shortly about the working group, I will just mention that it's a small working group really focusing on open BIM topics within the factory planning, and they will introduce it in detail. So I will now pass them the stage over.
So can everybody hear me and see the screen with the presentation now?
Not yet. Now we see your screen. Yeah.
Oh, we see it, yes.
And you can hear me? Okay, perfect. Yeah, thank you for the introduction, Mirbek. And then we start. Hello from my side. I would like to welcome you to our presentation, Open BIM in Factory Planning. My name is Lisa, and I will do the presentation together with Thomas Neuhäuser, as we are leading the expert group together in Germany regarding that topic. Unfortunately, we cannot be in Montreal today in person, but we're sending you a warm welcome from New Zealand and Cape Town, where Thomas and I are located today, to our presentation. First of all, I start with a really short introduction into my company, Building Information Management (GLW), which is a startup out of the Technical University of Dortmund and was founded by two colleagues and me in 2020. We are based in Bavaria nowadays and have a construction management and factory planning background. For that, we're offering our services based on 4 business units. With BIM Consulting, we offer our customers a guidance service on their digital strategy, as well as the introduction of the BIM method in their companies. BIM management services for projects, as well as BIM coordination, are offered within the second business unit. And with BIM 5D, we mean that we create models for our customers within the bidding phase for the execution of a construction project, and therefore do quantity takeoffs, variant comparisons, and the relation with cost data. But the last but not least one, and most important one for today, is BIM in factory planning, where we do, in several business units, as I did my PhD on that subject, offering various services in that field. For example, the creation of BIM models, as well as interdisciplinary collision and quality checks, combining building and factory data, variant comparisons to evaluate required flexibility of the factory building, as well as simulation methods, for example, when a new user likes to rent up existing factory building. So far, a brief introduction from my side. Now Thomas will take over with his introduction of the Fraunhofer Institute.
Perfect. Thanks, Lisa. Also, a warm good morning from my side. Yes, as Mirbek already said, I'm Thomas. I'm one of the group leaders at the Fraunhofer IGCV. ITCV is mainly standing for Casting, Composite, and Processing Technology. So we are mainly focused on different sides of production technology there at our institution. And at one of our departments, which is called Holistic Factory Planning, we have two different groups. One of them is regarding the sustainability of production systems, which is, you can say my neighbor group. They are mainly focused on how we can get rid of fossil energy supply in factories, how we can do life cycle assessments of different products and all this stuff. So they are really deep into sustainability issues, and my group is focused on collaborative factory planning. So how we can work together during the whole factory planning process, from the settlement of the objectives of the factory, of the future factory, until the ramp up of the factory. So what we are doing in my group is, in very general or in a very strategic view, we develop BIM strategies together with factory planning departments of manufacturing companies. So who does need which information when, what are the different BIM goals, what are the different BIM use cases they should address in their BIM strategy, how does the software landscape will further look out, and all this stuff. And if we are doing real planning projects, what we also do, we often start with laser scans, because you can say about 80% of factory planning projects are undertaken in brownfield. So there is already an existing factory which have to be replanned. So starting with a laser scan and generating a point cloud, then we generate our models which we need, like creating 3D plus E models, which are BIM conform, where we give the models different attributes which they need, and then we use these models to plan and simulate a future production system, and also to share these models, especially to the building planning side, and to other planners which are in this process. So far to our introduction, I would say. We have 6 points on our agenda today. We will first start with a short introduction to factory planning. Then we will have a look about the symbiosis of factory and building planning and what are the different project participants. And then we will go more deeper into our buildingSMART expert group, what we are actually doing there. And we will also introduce, for short, our research project FABIM, which is mainly focused on factory planning with BIM. And yes, I would say let's start with the introduction to factory planning right now. So if you look on the figures of, I guess it's from 2019 or 2020, we see that in Germany there are approximately 6,000 factory buildings which are built up each year. These 6,000 are just the subject to approval, which is, I would say, only one half of the factory planning projects. The other half are small planning projects which are not so big and do not have to be approved by the government or by any government constitutions. So there are quite more than just these 5,800 factory planning projects during a year, but this is just a figure which are subject to approval. From these 5,800 projects, you can see that 4.7 billion the project value. So you see these are sometimes quite big, sometimes small, but it's it's still a huge amount of costs which we have every year for factory planning projects. And we have different studies in Germany which indicate that around 60% of these projects will miss their cost targets by approximately 10%. So if we calculate this, we can say that around 280 million euros every year are additional costs to factory planning projects just to any inefficiencies in this process. And so our question is how we can get rid of these 10% and how we can improve factory planning projects or the factory planning process in general. And there we are with BIM. And BIM, has also different studies about it. There are also different studies about BIM. And we can see that, there is like a promise of a cost reduction about 25%. So it is definitely worth it for us to have a deeper look into BIM and to try to apply BIM on factory planning projects in order to reduce these additional costs and in order to increase the efficiency of factory planning projects. But this is not very easy, and I will try to explain it a bit by just the definition of a factory. So a factory in general is a place where value is created. So in a first step, a manufacturing company has the purpose to produce products, to sell these products to their customers. So they are really focused on their products development, and also on the development of the processes and of the production system of these products and these processes. So, but in a factory, you have quite more than just the product, processes, and the production system. You also have the building, which is quite important, especially when we try to apply BIM onto such projects. But in general, you can say in factory planning, the building is often regarded as just an envelope which protects the production system from not getting wet and from any environmental contacts or contacts with weather and all this stuff. So it's just there, you can say, the building. So the factory consists of the production system and the building, and we are very deeply focused on the production system, but not so into the building. And this is what we try to change a bit, especially about introducing BIM to factory planning projects. And we also have a big problem in factory planning that production systems are not so good standardizable, because almost every factory or every manufacturing company has their own construction departments which construct the individual machines for their production system. So they are not really standards. You can say there's not any library. You can say you just pick out these five production machines. So instead, you have to set up your models for your production system, for your machines which are standing there, for your equipment which is integrated in the factory building every time for the individual project. And this is one of the big problems which we have in factory planning projects. And on the other side, if we look on the process, how it starts, how the initial solution is, or the initial situation is, you can switch the slide, Lisa, please. There you see that if we look on real factory planning projects, you often have the planning disciplines, the object planning, very late in such a process and the project is already initiated. So if you are talking about BIM, which has these exchange information requirements, which has these BIM execution plan at the very beginning of a project, your production system planner has to be keen or has to be used to use BIM to introduce and to set up a project with BIM, and this is very often not the case. So if you're looking on just a small project, there we have an historical ground production, which is reaching its capacity limits. It is about 30,000 square meters of production system, which has to be relocated within the next 5 years. And you can see there that the planning of the production system is going on right now for around 2 years. And on the really right-hand side, you can see that there's absolutely no one yet which does the building design, which does the building planning. And yeah, it is mainly us who are planning the production system. It is the client who defines different requirements. And because we at the Fraunhofer IGCB, we want to plan, we want to build up, we want to construct the future factory with building information modeling, we said to our client, yes, let's take someone from the BIM management side into this project. So yeah, we were working together with Lisa in this project, and we set up the exchange information requirements already. So this is something special, but this is something what I would say normal production system planning companies don't do so far, because there are two little guidelines, there are two little use cases how to use factory planning, and it's really a long way to go to set up factory planning with BIM as a standard, I would say. And if we go to the next stage of to the next agenda point of our presentation, we will talk about the symbiosis of factory planning and building planning. And there we can see it also from the, I would say from the side of our guidelines. We have in general two main guidelines according to factory planning, or which are focused on factory planning, or which are focused on this process. This is the VDI 5200, which is mainly focused on how do we build up a production system. And then we have the HOI, which is focused on how we build up our building, or how the building and construction planning is done. And as you can see on the left side, the VDI 5200 starts in the first phase with setting of objectives, and the building planning does not start in this phase, it starts later on. So if the project is not set up by the production system planning with the BIM methodology, it will be hard to plan the factory as a holistic object, or it will not happen that the factory is planning as a holistic object with BIM. So it's mainly just the building side, and this is what we want to change in the future. We want to set up, and we want to give advice, to give help, especially to the production system planners, to set up projects already with BIM and to initialize their projects with the right documents, with the right concepts, with the right methodologies, and to give them also the know-how to do this. And this is what we are focused in our daily work. And I guess, Lisa, you want to talk right now about different use cases or different planning cases in factory planning.
Yes, thank you, Thomas. So yeah, to leave that up, VDI 5200, so the planning process for production system planning, and also the HOI in Germany for building planning and construction. we don't have to just combine that together. We also have a differentiation in factory planning use cases between planning cases, which means we have to take a closer look into greenfield projects, which are, I would say, for construction industry normal projects, like we have the Eberle one, which has to move out of the existing buildings and has to have a new factory site as well, and also at brownfield projects. So in factory building or factory planning, we have a lot of brownfield projects because a factory as itself is a very dynamic and complex environment. That means we have to take into account the transformability of a factory building as well as the flexibility when a new production machine is inserted because a new product has to be produced. We have new influences on the factory building, and for that we have to differentiate beside the combination of the planning processes also in different planning cases according to the factory, which means that it's really important to gather the data from brownfield projects and have their reliable BIM model or database as well for brownfield projects as for greenfield projects where we maybe have just a greenfield we can build on. So for that case, I developed an evaluation system, which I like to show you for decision support of factory building adaptation based on BIM, which can be used also for greenfield projects, but is initially designed for brownfield projects. I will give you a short overview of the 4-phase evaluation system now. Let's imagine, we have a greenfield project. For that, we know that we have to produce a new product with new production machines, or we have a brownfield case in that we have to change production machines because a better technology is available than the one in the existing factory building. For example, autonomous robots instead of machines that have to be partly operated by humans. So in phase 1, what we do, we have to combine the data of the factory building with the production system in order to evaluate it in different possible variants. That means within our example that we see right there on the screen.
Lisa, I would like to ask you a question. Are you showing us phase 1 currently? There's a slide.
Yes.
Okay.
Yeah.
Fine. Then everything's
that's right. Okay,
right.
perfect.
Thanks.
Yeah. So let's imagine we have 4 variants that would be possible for the maybe brownfield project or for a new greenfield project of the factory. Then we go with the BIM model into phase 2. Now I show you the model check in the phase 2 space requirements. So there we do some kind of, I would say advanced collision check, as we have to consider surroundings of a production machine, as well as space to bring in material for the production process or maintenance services. So we check the space requirements, not just of the production machine in that case, as well as the surrounding space that we need for the production line. I will give you an example later on. In phase 3, after that, we check with the 3 variants that would be possible, a model check or a quality check of the 3 variants that we have. What that means is we check we have different criteria that can be guidelines of the government, are escape routes met, or can be product requirements, is the distance of the dowels right that have to be inserted into the production system and factory to combine them together, or something like that. I will give you afterwards also a short example for that. But let's imagine we have out of that 2 variants that can be built. Then we go into phase 4 to the BIM evaluation, and there we evaluate the technical viable variants with focus on cost specifications, time, how long it will take to build the new factory, or to interrupt maybe the production system within a brownfield project where other products are in production. So we have maybe also other parameters that have to be considered in that case. So in the BIM evaluation phase 4, we make finally the decision let's imagine for the 2 variants, which would be the best to execute. To have a closer look into phase 1, the symbiosis of the data with the BIM model. Here, an example, we have different, for example, here the robots. We have the dowel to connect the robots because of dynamic loads with the factory building. And we have to combine the production machine or implement the data that is required for the building, or where we have to have interfaces, dependencies to the building of the production machine, like loads on the floor slab, as well as is electrical supply over there, or do we need air compression, compressed air for the production line or for the production machine. For that, we can implement the data geometrical wise, as well as the information, non-geometrical information, into the BIM model, just to check in the following phases if it's working. In phase 2, we check the space requirements, as I shortly mentioned. We have not just to implement the production machine itself, we have some surrounding areas, like for repair and maintenance of the machine, also provision area for fixtures and tools, as well as materials, work pieces, or control surface for a human that is on the production machine and installs different kind of stuff. So we inserted for that geometrical data to the production machine. Here, as you can see in the picture, like a surrounding, it can be different as you can imagine, but we have to take it into account to have full or advanced collision check with the building, because it's not working when we don't have that space in the surrounding of the production machine as well. For example, phase 3, we have the model check of the quality. For that, we have 3 action fields that we also consider within one working group in the BIM expert group, Open BIM in Factory Planning. Action field 1 is legal evaluation criteria, like, for example, is the escape route situation for the humans okay in the factory building? In action field 2, we have different rule sets for product specific influencing criteria, like, is the center distance of the dowels okay, or something like that. And in the action field 3, we have component specific interfaces and dependencies. For example, load on the floor slab okay, or is electrical supply nearby the machine, as well as are the technical parameters okay for the machine, that we have the influences or the interfaces between the building and the production line or production machine checked as well. We go further with evaluation phase 4. Therefore, we evaluate cost and time-wise. It's the BIM model itself. So here also the VDI planning, production system planning process can be implemented. So we see over there as well, we have to have an planning start from the production system planning team, I would guess, to start the planning of the building. And therefore we decided to do some kind of LPH 1 till 3 planning, to do the planning before the decision for a variant could be made, to get the most flexible factory building, or the best factory building for the use case. So we make a decision for different variants, for different use cases, and then we go into the realization phase. So we have to have the building permit according to the building or construction planning process, as well as we execute the building. Findings for that or out of that were to close that topic. We have a model-based reduction of planning times due to standardized database for openBIM process, which means that we have also higher transparency of influences between building parts and factory parts, and we know where we have influences between them, or we have interfaces. We have a model-based decision support it's possible directly with model checks in phases 2 and 3, and also the evaluation within phase 4, because in the end it is important not to evaluate or check variants that are not possible which are not sufficiently checked in phase 2 and 3. And important for the checks, so-called coordination of the model, is to take a closer look at the project participants as well of a factory, because we have on the one hand the building planning team, I would guess, and on the other hand the factory planning team, according to the processes that we already saw on the screen or slides from Thomas. And in the next step, I like to give you a closer overview of the project participants within a factory planning project. So we start with the building planning team, I would guess, on that side. Within a building planning project, we have different project participants, as we all know, and one leading partner, which is mostly the architect on the left side of the screen. In the different planning disciplines is a BIM author, which we see down below in every discipline, who creates the model, or if there is no model created, like in the fire protection planning or something like that, we have somehow an information deliverer, as we call it. So we have both options. A BIM model is executed. We have then a BIM author, and also we have just the information which can be delivered and implemented into the model, maybe from the architecture side or something like that. Above that, within the different disciplines, we also have a BIM coordinator, or is installed there, who ensures that the requirements out of the BIM execution plan are met. And of course, these functions in one discipline can be also taken over by one person. Yes. So when the disciplines created models or data, so for the information deliverer, they deliver it to the architect for overall coordination or check of the model within the building planning section. So we have then, maybe in different data drops, in different coordination loops, coordinated model. Normally we do it regarding or according the HOI in different planning phases, and we have in the best case after every service phase of the HOI, when we finish that, a coordinated model. To go on the next step or to the other side, factory planning. We have almost, I would guess, the same situation. We have some kind of leading role that could be the factory layout planning, and we have also different disciplines who are maybe have a BIM author or an information deliverer. As we learned already within the expert group, we have normally just an information deliverer, and at least the factory layout planner executes a BIM model, but it could be like this or that. So we have also here the same options over there. The process overall works the same way, so the information or BIM models are coordinated within the disciplines, and they will be delivered to the factory layout planning. In our imagination, or in our best case approach, the factory layout planner is the same as the architect, so he coordinates the factory planning overall, so that a coordinated model out of the factory planning, you can guess maybe according also regarding the VDI planning phases as well, is over there when we have the data drop and we combine it with the building planning. So let's get them together. We have there the factory planning on the right side, the building planning on the left side, and in the best case, or in the approach that we executed nowadays, we have a coordinated model for the building planning and also for the factory planning, because it makes no big sense to exchange the data between the different sectors, I would guess, even if it's not coordinated, like you can imagine in the evaluation system phase 2 and 3, if it's not coordinated in the discipline or within the section like factory planning or building planning, it makes no sense to coordinate the whole amount of data all together in different stages. So in our approach, we have different data drops. In the data drops, we have a coordinated building planning model and also factory planning model, and we combine them together. We have here a BIM coordinator, which also can be on that side the architect or also the factory layout planner, depends especially on the project and the BIM manager, and also the client as well. And the BIM coordinator over there coordinates then the building planning model together with the factory planning model, as we saw in the evaluation system, to make sure that the interfaces are okay, that we don't have any collisions that are not good for the project, and also to evaluate different variants where we can go, because we know we always have different variants that we can in that we can execute a project. And some maybe variant A is more cost intensive, and maybe variant B is time-wise better for a project because it takes not that long, and it's different because of if you have a greenfield or brownfield project, maybe you have not the time pressure in a greenfield project as in a brownfield project, where you interrupt a process line or production line which is which produces products already. So it depends on different influence factors on the project, greenfield, brownfield, and also on different variants that can be executed to find the best flexible factory for the overall system. I would combine that, yes. And now we go to the next point, the most important for today, the use case buildingSMART expert group, open BIM and factory planning. And then for that, I will again hand over to Thomas, who will explain what we do there in detail.
Okay, so in our expert group, one can say that we have kind of 5 different working groups, which consist of 5 to 10 different people, roundabout. So in the blue on the blue side, on the left top, you can see that one of our working groups is considering the digital twin of a factory. They are actually writing like a white paper. I know that there are many different papers, and there's done many work about digital twins, also combining digital twins with BIM. But I hope you got a short understanding so far that it's really something different to plan a factory than planning something from infrastructure or planning something just a building or something like that. So we have to have a deeper look in what a digital twin, especially in the field or combined with BIM, means of a factory. Then we have our group interdisciplinary collision checking, especially between production system versus building. There are defined some requirements. Lisa also mentioned of some of these requirements, which are really useful for collision checking. We have the group which is focused on continuous as-built documentation of a factory. They also try to write a white paper, because the interface between the construction phase or the handover from the construction phase to the operation of the factory, this is, in my opinion, it is the most crucial point in general projects. There are the most information losses, and there it's often happens that the BIM model then gets lost and it's not be used further. And on with the fourth group, we have the interface between production system planning and MEP planning, because this is really one of the crucial points, how we get all the media supplies to our production system. which we will also see on the next slides. And surrounding these 4 groups, which are focused on different parts of what is BIM and factory planning together, we have a group which will, in the next months, next years, try to have a deeper look into IFC extension for factories, because so far we have no entities, no specialized property sets, how we can describe the factory equipment, factory machines, and all the stuff in the openBIM data format IFC. Okay, and now I will go through these groups using a small use case, which is one of our machines in Augsburg. This is a machine for additive manufacturing of metal components. And as you can see, these machine has definitely different specifications. You can also say requirements towards the building, which is space. In the first step, it's just space. It needs space into the building. Then it needs different media supply, like electric power, air pressure, and also the metal powder to produce the products in the machine. Then you also have the unused metal powder extraction, which has to be taken out of the machine again after the process. You have something like a bearing load, and there are also some vibrations caused by the machine if when it's producing. You have like requirements regarding the particles in the air, which has like a maximum. You can also say that the machine requires or has requirements regarding the temperature, the surrounding temperature, and also the air humidity. And if you go on the next slide, you see that all these requirements can be addressed to different planning disciplines, which from the building side, which Lisa already shown in the planning participants. So the space, especially for the architect, quite relevant. Then you have a lot of different things which are relevant for the MEP planner. And you also have something like the bearing load, which is definitely very relevant for the structural engineer. So you have many interfaces between production equipment, between the production system, the production machine, and the building. And this is why we really need to apply to define these interface between production system planning and the building planning. And we try to do this, yes, as we already said, with BIM or especially with openBIM. And on the next slide, you can see that in one of our groups, which is focused on the interface between MEP planning and production system planning, we try to adapt the approach from the IFC tech box, which comes from the German expert group IFC for Lab. So we just have, like, for the machine or for the production equipment itself, for the geometrical representation, especially in the early planning phases, we just have a box, a surrounding box, or a bounding box of the machine, which is the approximate geometry. And then you have every interfaces to the MEP planning, like media supply, like electric, like ventilation, and all this stuff. And what they try to do, they try to set up this new entity in IFC with basic data, with geometrical data, other data, and in general with the interfaces to MEP supply. And if we done this, if this works, then it would be quite useful to don't use IFC, the IFC building element proxy, not further for production system planning. So instead, we can use the, let's say, the IFC manufacturing plant, IFC manufacturing equipment, And then we can try to use this openBIM process to build up our factory or our production system also as a BIM model, and we can make some collision checking to the building planning, which was also already quite good explained by Lisa. So I go quite fast over this use case of our expert group. And as I said, it would be really good to don't just have these bounding box with all the media supply, which is just representing the interface between MEP planning and production system planning. It would be really good to have in general the entities which we need for factory planning or for production system planning also in IFC. So maybe we can introduce an IFC production element, IFC manufacturing element, extend the IFC scheme by that. Then we have in there the IFC production plan. Maybe we will further have something like IFC logistics equipments, which are also entities to be used in the IFC scheme. We have some special property sets to be used there. And this is what we are thinking about as outcome of our use cases and as the input then in these IFC extension. So how we can integrate entities in IFC to build up or to model our production system. And if we modeled it, if we used it, if the factory has done its ramp up, then we generate lots of data in the factory, and we can definitely try, or we want to use these data combined with the model, combined with all the information of the model as a digital twin. It is clear that we don't need all this information, but it's a really good basis to start with the digital twin, to use some or most of these information, and then we will try to create or to bring some dynamics into our BIM model by integrating something like the current power consumption, the consumed air pressure, production parameters, like how is our product built up, what are the processing times right now, what is the quality of the product, and also some vibrations calls to really have a picture of the current state of our production machine in combination with the building. So we try to link real data with the model in the operation phase of the factory. This is what we are, investigating or what we are discussing about in our digital twin of a factory work group. And the last work group of our fives, we are focused on the continuous as built documentation. So you can say that a factory is really a living system. If you are looking on the automotive industry, you normally have every half year, especially around Christmas and in the summer break, you have normally 3 weeks where a lot of changes are made in the factory, or especially for the production system. So you have really a lot of changes over there in just a quick time. And you can say that the production system really changes continuously. And we also need like a continuous as built documentation for our models to keep them up to date, because I've never come in a project, or I've never started in a project and had any up-to-date plans so far. And this is what we try to solve this problem, to be up to date with our plans, with our models, with our information we have, to keep them up to date and to try to use them, to use the digital twin, to use our digital twin-based BIM model for the next planning phase, which takes place really continuously in factory planning. So there are steadily changes to production systems, and therefore we really need these continuous as built documentation. This is so far a short introduction in what our expert group is focused on. Lisa will now give just a short outlook to one of our research projects, which just recently started and will generate quite good, or hopefully really good, outcomes for us.
Thank you. Then I take over and we give a short outlook. Our project or research project that started recently in September 2020 is FAR-BIM, which means as well factory and BIM. Therefore, our vision or our big picture is also to take a look at the whole life cycle of a factory and develop an approach of a life cycle management platform-based CDE, common data environment. We meanwhile decided to take a closer look or focus on the phases execution and operation, as a lot of approaches focus on the planning phases within the FAR-BIM project. For that, we have different project participants in the project, which is also, for example, the Fraunhofer Institute as research facility. We have different enabler companies, which are we as BIM management, as well as IFP consulting as factory planner. We have contact software on board, which is responsible for the CDE, which has to be created. And we have different user companies, General Planning Kohlbecker, which is a big architecture and planning office in Germany. And also a factory operator, which is the use case that Thomas already introduced, Eberle. Broadcaster regarding the expert group in buildingSMART that we have, and also the VDI Association of German Engineers, where we have also some activities that I will show you later on. Just to give you a short introduction into that, we have different work packages. We start with work package 1 recently in September, as I mentioned, and we plan different work packages out of that. So the aim of work package 1, in short, is to develop an IDM based on BIM use cases that are relevant for factory planning. So now, or these days, we are in work package 1.1 specification of the use cases. For that, we took into account every BIM use case that we found in the world, I would guess, combined them together, and now we're rating them or regarding their importance for factory planning projects. So in the end, I think we will choose 2 use cases that we derive or will do an information delivery manual on and derive an IFC mapping for. In work package 2, concept of a common data environment, we're working with contact software, or in the lead with contact software, and we create a concept of a CDE and derive the data to our AR or VR solutions in the end, to use it during the operation phase of the factory, as it's one of our focuses. To combine them together, we have also a work package number 3, where we evaluate the project constantly within the next 3 years. So we will finish the project in September 2025. So we have a lot of time to execute everything and bring it together, or network together with the buildingSMART expert group, as well as the VDE group, where we do some activities as well. Scientific innovation, within FAR-BIM within FAR-BIM is based on directly BIM-specific use case for factory planning, or maybe 2. IDM for factory planning that we like to have a concept for or derive on. Attribute database for factory planning elements. Thomas already mentioned it is really hard, because every production machine is different, but we have I think a base data set that can be used for mostly of all the factory planning elements in factory planning, that can be attributed database for IFC entities out of that for factory planning, and a CDE focused networking concept. Within technical innovation, we based on BIM-based common data environment as well as a BIM2 field-based approach, relocation logistics based on as-built digitization using laser scanning techniques or others, and especially AR, VR-based building and IoT data provision, especially in the factory operation phase. Our overall vision or target, I would guess, is to create a tested in practice open BIM-based factory approach that can be directly used in future projects of our FABIM partners, and as well we have a CDE out of that, so I think we can use it properly well when we tested it maybe in the BR2 project that was introduced by Thomas as well. So let's come to the small short outlook that we have. What's coming up next is we have the network between the buildingSMART expert group and the Association of German Engineers. Within the Association of German Engineers, an expert recommendation for BIM and factory planning is in work in progress, I will guess, and also a guideline for information exchange requirements for factory layout planning. As I mentioned, as we spoke about, or I spoke about the project participants, the factory layout planner is a leading role. We also take a closer look into that. So we define the most important terms as well as the intersection between BIM and factory planning within the expert recommendation, as well as a definition of participants, organizational charts where you saw a short overview of, and also definition of modeling content via the factory planning process. So the level of development and also some kind of level of coordination will be developed there. In the guideline, definition of information exchange requirements in factory layout planning as well as IFC mapping is planned, and nowadays already work in progress. And of course, we continue our work in the expert group Open BIM in Factory Planning in order to achieve our vision of a collaborative Open BIM approach for our future factories. As we can see here on the right side, common planning approaches to come or to know where we have link between the VDI planning approach and as well as the HOAI, especially for greenfield and brownfield projects, organizational life cycle assessment, and also from a technical perspective, overall model and synchronized submodels, as we know that we don't have one overall model for everything, not in construction or building planning, as well as not in factory planning, and especially not in factory or BIM in factory planning. So overall model, which is the coordination model in synchronized submodels, as well as in future maybe a digital twin and standardized data exchange format. So that means especially, yes, the development of the IFC standard in direction or in the right direction to factory planning. So the factory overall means production system and building linked organizationally and technical across the life cycle for us, and that's our vision that we have for our expert group in the future. And I think we have a good background in Germany nowadays with research project as well as with the network to the German Association of Engineers. But if there is someone hearing our presentation and from across the globe, I would guess, who is interested in it, we also open for exchange or networking in everywhere or over all the world regarding the projects. Thank you for your attention, and we are happy to answer your questions if we have a little bit time. And to get in contact with us, you have here our contact details, so don't hesitate to contact us at any time. Thank you.
Thanks so much, Thomas and Lisa. Thank you. Switch to any questions here in the room? I can walk this mic around if there's questions that anybody has for them. What? Oh, okay. Anything? Is there anything online? Can we look at the chat?
Checking. Not so far. No
Okay.
Questions.
No questions, but you have a question?
I I would like. Yeah, I have. You also have a question. You go first.
Okay.
So you have a question. I may add something.
I wondered if you could expand a little bit on the details of the AR VR overlay for the equipment in the MVD, if there are any. Like, what does it entail, the AR VR overlay?
So you mean considering our research project?
Yes.
Okay. So I guess this
I mean,
is
if
kind
there
of,
are none, it's fine. I was just curious.
yeah, it's it will take place around year 2025.
2020.
I would guess.
Yeah. It's the last element of the work package 2, I would guess. So we don't have any MVD for that, I would say, but we have an idea what can work during the operation phase of the factory building and what we need to know regarding the AR and VR approach, especially maybe for the maintenance services of the production machines, as well as the interfaces to the electrical supply or compressed air. Is there enough? If we have to, and also the whole circle of production machines together to combine that.
Yeah.
You know
Okay.
what I mean?
Yeah, no, I'm glad that it's included. It's nice to see in there because I know, like the aviation industry, places like Boeing have been doing that stuff with like wiring diagrams and things for a while. So it's good to see it coming to the building side here.
You exactly. That was exactly the point there. I wanted to actually ask to mention, and within the working group, they are trying, as you already mentioned, they're trying to work on an IDM and some defined use cases until the IDM. Okay, and the most important thing that I think some is the
Probably crossover.
yeah, crossover. So the most important thing here, they need to identify taxonomy, what's in factory planning, exactly this equipment that Thomas and Lisa presented. They should be available within the schema, and necessary entities and their predefined types, of course, their related properties should be enriched. So that's possible, would be done through the exchange requirements, and then later on with necessary mapping, and maybe later on when we have enough capacity. First of all, we'll proceed with MVD and then with IDS, whatever will come later on. And currently, the working group is focusing on something important, that these use cases will be brought into UCM, use case management service from buildingSMART International. And as far as I remember, there's one more additional call. It was to open to international community and go to BSI through the activity proposal, try to bring this project into building room. So this is that's why we are trying to attract more supporters for this future cooperation. And of course, until then, we have to deliver something and bring this work further. And I hope that this particular working group will come as an international working group into building room then. Thank you for your great presentation, and I will give to David for a closing.
Yeah, we're done. I mean, if there's no questions online and there's no more questions in the room. Oh, here we go.
Yeah, hi. I'm coming from the perspective of architecture. And we do work on warehouse buildings where we deal with automation, not quite a factory. The issue we have, with kind of any digital twinning is, of course, the content creation itself. I mean, creating a digital twin is easy. It's technically feasible. There's always a question of time, adoption, willingness. In your schema, who is the most important player in that adoption?
Mm-hmm. It depends on what you are doing down there, because I think the issue is you have to know what you like to do with the virtual twin, or what kind of data you need out of that. So which use case you like to do, or what you need. And then it depends on the use case. So for example, if you like to have something regarding the electrical machines or electrical supply, it's the MEP planner, I would guess. Also in the operation phase, because you have to update the model all the time, and afterwards you have a build model, and then you update the model, and if is something going wrong, you have to have someone who is responsible for the whole planning of the system. So I would guess it depends on what information or data you need for what use case and what you like to do with the digital twin, because it's always different what the people are doing with that. And I think in most cases it's not clear. They just create a build model with all the data, then they don't know what they do within the operation phase with the warehouse, or with the data of the warehouse, maybe for maintenance, maybe for rental management or something like that. It's a different use case, and afterwards you just have to define what you have to have. And I think then the responsibility for updating the data depends also, or is also related to the participant of the specific planner, like MEP, like the architect or something like that. Because I don't think that you like to update the MEP model as an architect.
Okay, that's fine. So, thanks.
Yeah, any other questions? There's nothing else online. So I think we're done. Yeah, I would echo Mirbeck. Great presentation, really thorough and just so deep. I thought it was great. Thanks. So I guess you guys are off the hook, ready to go back to lounging about, having fun for the day. And
while sleeping.
Yeah, cocktail time. We can go have some water and a bio break. So, all right. Thanks all.
Thank you.
Thanks.
Thank you. Goodbye.
Bye.
Bye.